I think it's more Victorian era that we've continued on over the years. No, most likely that was named after somebody.
That's a brand. Not just underwear.
Because Maybelline.
Yeah, that's underwear. They're comparing it to blush though.
They make a bunch of stuff. Victoria's Secret makes makeup. You're actually dumb.
Guys.
Victoria's Secret does not make makeup. No, you are. Did not say
I'm wearing blush.
Let's focus up here. Complex conjugates theorem. If a polynomial f has its function with real quotient a plus bi, then a minus bi is also true. So if a plus bi, if we have it, its complex conjugate is a minus bi. If a minus bi is what we have, its complex conjugate is a plus bi. If we have one, we have to have the other. So if we look at this first one here, so the first one we're looking at is 7 minus I. Its complex conjugate would be 7 plus I. Almost. First half. Now what's interesting with complex conjugates is if we take them and multiply them together, something interesting does happen. So if we do 7 plus I times 7 minus I, well, 7 times 7 is 49. 7 times I will be plus 7I. Negative I times 7 is negative 7I. And negative I times I is negative I squared. Now we do need to simplify a little bit. Well, there are no like terms currently with 49, so it stays the same. What's our 7I minus 7I? 7.
It's just
7I minus 7I.
oh, 0.
Yeah, 0. And we said yesterday I squared is negative 1. And well, 49 minus negative 1 is the same as 49 plus 1, which gives us 50. So we started out with two terms that both had I, and we multiply them together, we get a real number. So when we multiply complex conjugates together, the I terms simplify out. Now if we look at the next one, negative 5 minus 5I, its complex conjugate would be what?
Negative 5 plus 5.
Negative 5 plus 5I.
Then would you do negative 5 plus 5 minus 5I times negative 5 plus 5I?
Either order, yes. Because we could have done the negative 5 plus 5I first, then negative 5 minus 5I. We can multiply them together. Now, throw that out. We could do this in a calculator. We could say negative 5 plus 5I times negative 5 minus 5I, and we get 50. It is coincidental that both of the first two work out to be 50. Now on the worksheet, the homework for this here, it will ask for the complex conjugate and their product. So for the second one, we would be looking for negative 5 plus 5I, which is the conjugate, and their product in this case would be 50. That's it. Because when we multiply them together, negative 5 times negative 5 would be 25. Negative 5 times 5I would be negative 25I. Negative 5I times negative 5 would be positive 25. And negative 5I times 5I is negative 25I squared. Well, the two middle terms cancel. We still have our 25 minus 25 times negative 1, which would be 25 plus 25, which is indeed Also, the graphing calculator will multiply them for us. So this one here is 20. What's its complex conjugate? Right, so the product would be negative 2 plus 4i. Yes, negative 2 minus 4i, which would indeed give us 20. Now, its complex conjugate would just be the negative 2 minus 4i. So if we look at the complex conjugate of 3 minus 6i, it would be?
3 plus 6i.
Mm-hmm. It is indeed 45. Questions on this here? Ten minus 2i would be?
It would be 10 plus 2i. 104. Negative 4 plus 8i.
I want to say 80. Very good. Okay.
Negative 4 plus 3i.
And then we plug it in, we should get 25, yes? And then the next one would be 8 plus 3i. $73. Now, we need to write this in standard form. Standard form does not have I in the denominator. Now, y'all can go on and try typing these in to the graphing calculator because we can do alpha y equals enter to get our fraction. Then do 4 plus 3i over 1 minus 2i. Yeah, it's going to say error because the 84 plus that we have doesn't like these. Don't know why. Because the next ones that came out immediately after these, the CEs, do it just fine. The 84, the 80 ones or 84s that you have are able to do it. There's a trick to it. We'll learn it in a little bit. But I'm going to show you how to do this by hand first. Because what we're wanting to do is get I out of the denominator, the bottom of the fraction. Well, we've already seen that if I multiply by its complex conjugate, I goes away. It simplifies out. So we're going to multiply, if we do this by hand, we would multiply the numerator and denominator by the complex conjugate. So here would be 1 plus 2i. And if we did this product, on the bottom we would do 1 times 1, which is 1, then 1 times positive 2i, which would be positive 2i. Negative 2i times 1 would be negative 2i. And negative 2i times 2i would be negative 4i squared. We'll also do the same thing with the numerator. 4 times 1 is 4. 4 times 2i is plus 8i. 3i times 1 is plus 3i. And 3i times 2i is plus 6i squared. Now the denominator will still have 1, but our positive 2i minus 2i is 0 minus 4. Well, I squared is negative 1. So we indeed have no i's left in the denominator. Now the numerator we have 4 plus 8i plus 3i is 11i plus 6 times negative 1, because both of our I squares turn to negative 1. Now what that tells us is we have in the numerator, our 6 times negative 1 would be negative 6, so we have 4 minus 6 plus 11i. In the denominator we have 1 plus 4. Well, 4 minus 6 is negative 2, plus 11i over 5. And that's it. Well, the only other way to write it is we can actually split the fractions up, which will tell us it's negative 2/5 plus 11/5 I. I will take either one. Questions on this here? All right. So 1 minus 4i over 2 plus 3i. Minus 4. Yep. Yeah. You got 84 plus CE. Which one is it? Hold the case. No. Yeah, KP, go on and get a new one because I'm going to have to clean that. It looks like battery acid. Because I'm thinking it's just battery acid. 2 of the batteries went bad at some point, and they finally are just toast. So, and for the most part, battery acid in AA batteries, AAA batteries isn't super harmful, but it's not good for you. Because no battery acid is, but it's not going to really do any major damage unless you start ingesting it. Battery acid in a car battery will eat through your clothes. Yeah, you don't want to mess with it. Yeah.
Will it eat your skin if you put it on it?
It will burn it pretty bad, yeah. And if you intentionally do it in a malicious manner, they can charge you probably with assault or anything higher.
Well, what
Is it usually that attempted murder?
Well, that'd be up to. All right. Now, we've seen already that these do not work in the calculators that we have. So we have to do it a little bit differently. Now what we're going to do is, instead of using alpha y equals enter, we're going to rewrite it a little bit differently. I've said that a few times now. But a fraction is just another way to say division, because numerator divided by denominator. So the way we have to type these in is the numerator inside parentheses divided by the denominator. And you do need the parentheses, otherwise it will give you a different answer. So when you type it in, we'll do parentheses 1 minus 4i, close parentheses, divided by 2 plus 3i. So go on and type that into the graphing calculator. And once you get it typed in, hit enter. So we got an answer, yes? Did you put parentheses around it? Division. We're not doing multiplication because we're dividing. Because a fraction is the same as division. So we do parentheses 1 minus 4i, close parentheses, our division key, parentheses 2 plus 3i. Hit enter. Yeah. We get decimals. Okay? We're ready for the next step. Because we need to convert these back to fractions. So if you hit math, the first option is fraction. So hit enter. Math, enter. And it should look like this. A-N-S, arrow, F-R-A-C, yes? Hit enter one more time. Under alpha. Enter, enter. That's it. Question? We ready for the next one? Okay, let's look at another one. 2 plus 5i over 4i. So if we're doing this in the calculator, we would do parentheses and what first? Our 2 plus 5i. Plus 5i. Close parentheses. Divided by, open parentheses, 4i. We may or may not need the parentheses around the 4i, but it's better to have it. Enter. When you get typed in, hit. Now, we will want all these in fractional form, not decimal form. And to convert back to a fraction, we're going to do math, enter, enter. So it is. Yeah. One plus 4i over 2 minus 3i. Yep. I think it was 2 minus 3i, yes? math. Enter, enter. Yep. I think at this point you all have it, yes? Go and finish the worksheet. Well, I just gave you the homework. For it, the homework's just a worksheet. Go on and finish it.